Okay, now we have to finish lesson 5.3. If we recall back to about a week and a half ago, we did derivatives of the e to the x function. And the derivative of e to the x was very simple. It was just e to the x. Nice and easy. That's a sloppy x there. However, if you had something a bit more complicated when you were doing a derivative of e to the x, like if you had e to an expression, like e to the 5x squared plus 8x minus 3, and you wanted to do the derivative of that, well, you would use the chain rule essentially. You would do the derivative of the outer function, which is just the e function, so it's essentially just the same thing that you'd rewrite, times the derivative of the expression in the exponent, so times 10x plus 8. That's the chain rule, right? Now, in today's video, we're going to discuss integrals, which is going in the reverse process of derivatives. So if the derivative of e to the x is e to the x, then the integral of e to the x is also e to the x. But just keep in mind that you have to add your plus c when you do an integral. So the integral of e to the x is e to the x plus c. Now, if you have something more complicated, instead of having just an x in your exponent, if you have an expression in your exponent, like e to the u, you'll have to use u substitution. Okay? So we're going to see that in the first example down here, right below. If you want to integrate e to the 3x plus 1 power, what we're going to do is we're going to use u substitution. We're going to call this whole thing, this expression up in the exponent, we're going to make that our u. We're going to sub in u for that. Okay? And then if you recall how to do u sub, you do the derivative of u, which is du, and then you take your derivative of your expression, which is just 3 dx. All right? Now, we have to consider what's left over in this integral. We have a dx there, but we don't have a 3. There's a 3 missing, right? So what we want to do is divide that 3 out of there. So this becomes 1/3 du equals dx, and that's what we're going to sub into our integral in our problem. So this integral, e to the 3x plus 1 dx, we're going to sub out all the x's and sub in u's. So this becomes e to the u, and then the dx becomes 1/3 du. That's what we're subbing out. We're subbing out dx for 1/3 du, because that's what dx equals. Dx equals 1/3 du, as seen right there, right? That's what dx equals right there. So now we could do this integral. The 1/3 is just a constant, right? So this becomes the integral of 1/3 e to the u du, which is really just 1/3 e to the u plus c, because the integral of e to the u is just e to the u plus c. And then we finalize it by subbing out our u and subbing back in our x expression. And that's it, 1/3 e to the 3x plus 1 plus c. And you could check it by doing the derivative. If you did the derivative of this thing, you would keep it all the same, and then you'd multiply by the derivative of what's in the exponent, which would multiply by 3. And that 3 and the 1/3 would cancel out, and then you'd be left with your original problem. Your original, what's inside the original integral. All right, so you're going to use u sub for these. Let's do this one also. This one looks a little bit more tricky, but essentially what you're just going to be doing is subbing the exponent. Whatever the exponent is on the e, that's basically going to be your u. But then you have to alter the rest of your integral to get it to match up. So if we do du, it's going to be negative 2x dx, right? But if you look in the rest of the integral, we have 5x dx. So we need to adjust our du to equal it to 5x dx. Right now it's equal to negative 2x dx. So essentially what we have to do is multiply by negative 2.5 to do that. So negative 2.5 du equals 5x dx. I know I changed the color up on you here. Hope you didn't get confused by that. But so see how this is a 5x dx here now? And that basically takes care of everything in our original integral. So this integral becomes, instead of 5x dx, we now have that equal to negative 2.5 du. Right? And we have our e to the u. So this integral becomes e to the u times negative 2.5 du, which we could just clean up a little. We could write it as negative 2.5 e to the u du, which the integral of e to the u is just e to the u plus c. That negative 2.5 stays in front. That's a 5 there. Negative 2.5 e to the u plus c. And then we would sub out our u and sub back in our negative x squared. That's it. That's a 2 exponent right there. I know it's a little sloppy. Right there. And that is your integral. So you have to, whenever you do integrals of e to the x functions, you have to use u substitution. Okay?